Welcome to qnawire.
Here, unfortunately, the image is not clear what we need, but in this type of problems, the most frequent thing is that we need to calculate the equivalent resistance for the circuit that we're going to have. So, as you can see, we are going to have different possible resistance. I'm labeling them as R1, R2, R3, R4, R5, and R6. And we're going to write down equivalent circuits that are going to correspond to the reduction of all of this. So first of all, let's notice that R2 and R3 are going to be in series. So we can generate an equivalent resistance R23 that would be equal to resistance 2 plus resistance 3. If we do that, our circuit now is going to look like, after the first reduction, like this. Okay, now the labeling is going to be over here R23, R1, R4, and R5 and R6. Now to reduce this further, we notice that R4 and R5 are going to be in parallel. So that means that the equivalent resistance 1 over R45 would be equal to 1 over R4 plus 1 over R5. So you're going to plug in the values and solve for R45. And after that reduction, the circuit now is going to become resistance to 3, resistance 1, over here. Now, instead of having a parallel circuit, we're going to have in series again here, and the labeling would be that this corresponds to resistance for 5 and this would be resistance 6. Now we can further reduce the circuit, noticing that these two guys are in series and that at the same time would be in parallel over here. So I'm going to write down the resistance 456, which would be equal to resistance 45 plus resistance 6, since both of them are going to be in parallel, and we're going to call the new circuit, which now corresponds to this. R23 in this position. Now over here we're going to have R456, and over here we now have resistance 1. Finally, we can reduce further the circuit with this value over here. That is going to correspond, I'm going to use this new resistance is going to be resistance X, let's call it, just to not repeat the names. In this case, resistance X would be equal to 1 over resistance to 3 plus 1 over resistance 456. Remember that on each of the steps you need to solve for the values that I'm giving here, replacing the numbers that are given to you, okay, for you to be able to get the result. So now the new circuit is going to be way simpler. We're going to have R1, we'll write down in notation, and a new resistance that is resistance X. Both of them are in series, so the equivalent circuit would correspond to a single resistance with the voltage. Let's call it R equivalent, and R equivalent would be equal to R1 plus Rx. So with that, it would be all. This is how we reduce the circuit to its minimum expression, and that would be the equivalent resistance for the full circuit. So you just need to replace the values in order to get your calculations. And for example, with that, you can calculate the value for the current if a difference of potential is provided.